name is Basit and today the topic that we are going to learn about is structures from computer programming course with the course 6900. So what are structures? Structures are a different type of variable which is user defined. Until now we have seen a different type of variables. For example, we have seen arrays, we have seen strings, characters, ints, floats, and so on. But all of these were defined by the compiler themselves or the programmer who had written the compiler. So now you want to work with a newer data type which you create by using all of these different types of variables. So that particular variable would be called a structure. And a structure can have int at times and floats, or it can have character and floats. It can even have arrays and floats, or any combination of all of these primitive data types. So essentially you are creating a new data type, you are giving a new data type to the compiler to be used. So what is structure? Structure is a user defined data type in computer programming which allows us to combine data of different types, which I have just explained, that you can combine all of these in different combinations and different sequences and different numbers. You can combine in different sequences, different numbers and different combinations to create a new data type. It is similar to an array, but an array holds data of similar type only. So it is similar to an array. How is it similar? Because similar array also has multiple variables. Similarly, structure has multiple variables, but the variables of structure are of different types. But for the case of arrays, it is not like that. For array, they are all similar to each other or same. They are all same, not similar, same. So, but structure on the other hand can store data of any type, which is particularly more useful. So, it is just explaining what I have just said, that structure on the other hand has variables or different data types. Structure is a user defined data types which allows us to combine data of different types together. So, you can combine different types of data together. Structure helps to construct a complex data type which is more meaningful. For example, if you want to write date. So, now date has ints in it and date has special characters in it. And there is no data type in computer programming, primitive data type, which can be used to declare date type of data structure. So, what you do is that you use a structure to declare date. You combine ints with characters, and after combining those you are able to use dates. Okay, so the basic syntax of a structure I have just given. So, if we look over to this part of the slide, we can see we have used a struct keyword. This is a special keyword. This is a structure name. These are the opening and closing scope curly braces, and then we have two variables. So, this was a template. You have to follow this template whenever you have to declare a structure. So, what is the template? You use a keyword struct. This keyword is fixed. So, you cannot write the structure with small s. It has to be capital. It is a keyword. It is case sensitive. Because of its case sensitivity, we cannot use a small s with the struct. So, then comes the name of the structure. You can use any name at the time of declaration. However, once you have declared the structure, then you cannot use a different name other than that structure. Once you have declared a structure, then you cannot change the name. But before declaring the structure, you can actually change the name. You can use any name for the structure. For example, if we have a person structure, we have a struct keyword. This is a keyword, and we have given the variable name or the structure name to be person. And then the person has three variables in it. It has a salary, which is denoted by float. It has a CIT number or customer or person ID number. You can even write it to be PIT. And then we have a name, array of name. So, it is a character array. As we have already discussed in strings, we can write the strings in the form of character arrays or strings themselves. So, you can use either one. Here we have used character array. So, this is a type of a person. We have created a variable to define a person in the programming or in C++. Here is another structure which we have declared. We have used a struct keyword, we have used pointer or point name of the structure, and then we have two variables in it, int x and int y. So, if we have to declare a variable of this point type, what would be the syntax? The syntax would be really simple. In the main program or wherever you want to declare the variable of point type, you use the keyword struct, you use the name of the structure, and then you give the variable name. P1 is the variable name. So, we can access x and y by using p1.x and p1.y. Here we have so we have done the same thing with a different structure name. So, we can also see that struct s, int x, int y. We can also declare the variables in single line also. For example, if you had two variables int x and int y, you can combine these two declarations in the same line by writing this. So, we declared the variable x and y in one single definition or one singular declaration, and then we create the variable of a structure. By creating the variable of a structure, we use the struct keyword like again, then we give the structure name and then give the variable name, and we have declared the variable name and the values to be 0 and 1. So, whenever we print p1.x and p1.y, we would get 0 and 1. So, memory of a structure. How much memory a structure would use? In the case of an array, if we had declared an array of 4 size of int type, what would be the size of an array? I have discussed in the array lectures. The size of the integers take 4 bytes. So, if we have 4 bytes and 4 integers, then that would take 4 into 4, 16 bytes. But how would we determine how much memory a structure is taking? That is dependent upon the type of variables which we have declared in the structure syntax. For example, in this particular structure, we had declared 2 variables of int type. So, it would use only 4 bytes, only 8 bytes, because 4 byte for one integer and another 4 byte for another integer. On the other hand, if we had a different structure, for example, if we had an employee structure, how much memory would it use? So, let us go over the memory usage diagrammatically. In this diagram, in this schematic diagram, you can see how much memory this particular structure is using. So, it has an integer, it has a character array of 10 bytes or 10 characters, and then it has a float. So, how much memory it is using? This is 4 bytes, this is 10 bytes, and this is another 4 bytes. So, in the memory or in the RAM, the structure would be declared like this. First, the integer would come, then along with its 4 bytes, then the character array would come along with its 10 bytes, and lastly 4 bytes of float. So, it would overall take 18 bytes of memory. So, here is the calculation. The size of integer is 4 bytes, size of character is 1 byte, size of float is 4 bytes, because we have 10 characters. So, it would take overall 10 bytes. 4 bytes, 10 bytes and 4 bytes equal to 18 bytes. So, that is how you calculate the memory of a structure. So, if you are given a structure and you are asked to calculate the memory of that particular structure, you can use this diagram, or you can develop your own diagram to calculate the memory of that structure. So, we have now let us see how we declare the variables and how we declare structure variables and use them. Suppose we had a structure, suppose we declared a structure like this, a transistor, a structure to show the working of a transistor. So, a transistor would have manufacturer ID, it would have a polarity, it would have a float, it would have a gain, and it would have a stock. So, if we are to calculate the memory usage of it, first 1 byte, then another 1 byte, then 4 bytes, then 4 bytes, and lastly also 4 bytes. So, 2 floats, 1 integer, that would be 12 bytes, and then 2 characters, so that would be 14 bytes. So, overall this structure would take 14 bytes in the memory. So, if we are to print the values or get the values of the structure, we would just create a variable of that particular structure, transistor rack equal to transistor rack A, and then we would access it by using A dot polarity, A dot power, A dot gain, A dot option. So, you can also verify the input by printing it, A dot power, A dot gain, A dot stock. All of these variables would work just the way normal variables work with C in and C out. There is no difference. There is no difference between the working of a structure variable from the normal or data primitive variables as far as the input IO stream functions are concerned. Here we have another structure example. You can see we have declared a structure of vector type. It has 3 integers, int x, int y, int z. You can also declare the variables of a structure like this or like this. In the newer versions of C++ from C 11 point something onwards, you can, all of these are equivalent to each other. You can also declare it like this and also declare it like this. So, we have used the newer syntax. So, we have 4 bytes here, 4 bytes here and 4 bytes. So, this is overall taking 12 bytes. We have declared the vector to be like so. We can initiate the variable values of the structure by creating the variable of the structure. So, if we have to create the variable of the structure of the variable, so what would we do? We would use this structure and then we can access x, we can access y and we can access z by using v1.x, v1.y and v1.z. So, that is how I am pretty sure that it is working over here as well. So, vector A, it has declared vector A to be like so, vector B to be like so, and then if we have to print the values, we are then sending these values to a function. Here function is written. If you see this portion of the slide, there is a function dot product. What it is taking? It is taking 2 vector structures and then it is multiplying the corresponding structure variables with each other. For example, it is multiplying A dot x to B dot x, A dot y to B dot y and A dot z to B dot z, and it also returning a variable. So, it would have an int type here as well. So, it is just giving us the output of the variable in the form of an integer. So, if we had supposedly we declared A dot x equal to 5, A dot y equal to 0, A dot z equal to 1, and we declared v dot x equal to 1, b dot y equal to 0 and b dot z equal to 2. What would be the answer of after applying this formula? You can just put it and check it. A dot x into b dot x, what would that mean? 5. A dot y plus a dot y into b dot y, what would that mean? 0 into 0, that is 0. A dot x into b dot x, a dot z into b dot z, that would be 1 into 2. So, that would be 5 and 2. 5 plus 2, that would be equal to 7. So, we would get 7 in the result here. Let us go over another example using the structure. So, we have structure of student data here. We have a character pointer which is pointing to a character variable, and then we have student ID and student age. So, if we have to declare a variable for using this particular structure, what would we do? We would use struct keyword, we would use the structure name, and then we would use a variable of the structure, variable of the structure. So, student is a variable of the structure. So, we can access the variables within the structure by using student dot stu ID, student dot stu name and so on. And here you can see the example. Student dot stu name is Steve, student dot stu ID is 1 2 3 4, student dot stu age is 30, and if we are printing them, then we can just use cout with them, cout, and then you use student dot stu ID, and we would get this particular 1 2 3 4 value. You can go over all of these one by one. You can write, I encourage you to write your own structures and then print their values or use them in arrays or try different techniques, so that you are able to familiarize yourself with the working of structures. So, there is another thing which you have to understand, which is a little bit complex than simple structures. A structure can itself be a part of another structure. So, these structures would be called as nested structures. Nested structures are those structures which contains other structures as their members. For example, if we had declared a structure of address type, stu address, it would have street, it would have state, it would have city, and it would have country. And then we have another structure, stu data. And in all of these stu data, we have stu id, stu age, and stu name. All of these things are normal variables. However, in the last variable is struct stu address, stu address. So this is another structure whose variable is working. Structure variable is acting as a normal variable in a structure. Structure variable is acting as a normal variable in another structure. So how do we define, do we get the data with these nested structures? So we declare the variable of the bigger structure, which includes another structure. So struct stu data, my data, and then we access my data dot stu id, easier to access, my data dot stu age, easier to access, my data dot stu name, easier to access. However, to access my data dot stu address and then street, we have to make it a little bit more complex. So how do we use it? My data dot stu address dot state. So we have to reference it twice. Here we are referencing the variables once, but in the case of nested structure, we have to reference it twice. So by referencing it twice, by using struct 1 dot struct 2 dot var name. So if you can see, my data dot stu address, my data is pointing toward this structure, and then stu address is pointing toward this structure, and by going over to the first structure, we go over street, state, city, and then country. So we can access the state, we can access the country, we can access the street. So that's it for today's lecture on structures. I hope that you were able to understand it, and I encourage you to write exercises and to write code your own self to understand structures better. Thank you. Allah Hafiz.